Alright, last video. So suppose we are interested in finding the fourth term in this particular expansion. We see 2x minus 3y raised to the seventh. Now we are not looking to expand it all out. So if there is a power of 7 here, we know there's 8 total terms. Out of the 8, I only want the fourth term. So this is where we are going to use our binomial theorem and choose r, and then a to the n minus r times b to the r. Okay? Remember, this piece here is sometimes written as nr. So in this particular case, if I want the fourth term, that means right off the bat that my r value is 3 in this formula, and my n is always that power. So I'm looking to find 7, choose 3, okay? And I need 2x, that is my a, that's the first part of my binomial. I'm going to put that in parentheses and raise it to the 7 minus 3, okay? And then I have my negative 3y that I'm going to put in parentheses, and that's going to be raised to the power of 3. So if we were to look at Pascal's triangle, which we're not going to because this is pretty far down the line, we're looking at the 7th row, which would have 8 terms, and out of those 8 terms we want the fourth one in. Okay, so again, this is the easier way of finding it. We're going to assume that we're allowed to use a calculator. So right now hit pause, find 7, choose 3. So if you did that, you would have gotten 35. Okay, and from there we still have to do this 2x to the fourth and then this negative 3y cubed. So again, we need to distribute that power of 2. So that's going to be a 16x to the fourth. This would be a negative 27y cubed. And let's go straight to our calculator. So we would end up with negative 15,120. We don't care about 3 sig figs here. In general, the rule of thumb is if you have something that is exact, you always write down the exact answer. Okay, we're never going to chop something and write it as 3 sig figs. Okay, it's only if you have something that is not a clean answer. Keep in mind that if the question said to find the coefficient, alright, if it said find the coefficient of the fourth term, that would only be the 15,120 number, so you would not include the variables. So sometimes you will see word problems that say find the coefficient of the term, so that would only be the number in front. In this case it says find the fourth term, so we want the entire thing. Alright, next example here. Suppose we want to find the constant term in this expansion here. Now by constant term, we don't mean the term that is not changing. We don't mean that connotation of the word constant. Instead, when we hear constant term, we mean the term with x to the 0 in it, which in turn is going to remove the variable and just give you a constant or just a number. Okay, so we're looking for the term that does not have an x in it. So it's not immediately obvious which term number we're after. Okay, so if you were to take a look at this, notice there's just a single x in it, and it shows up in the first position. Now, that's what we called a before. So we know there's going to be 7 total terms because the power is 6. So we know that the first term would have an x to the 6th in it, the next term would have an x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and then x to the 0. So there's our 1, 2, 3, 4, 5, 6, 7 terms. I'm only focused on the x part of it, okay? And we can see that it is going to be the 7th term that we are after. Okay, the 7th term would be the constant term. Again, that means you'd have an x to the 0. So that means we're really after, since it's the 7th term, we know that the r value is 6. So we would have 6, choose 6, and then we would have x raised to the 6 minus 6, right? We're doing our binomial theorem again. times, and then we would have 2 to the r, so 2 to the 6th. Alright, so that's going to give us 1 times x to the 0. And we knew that we were going to have an x to the 0 anyway, right? So when we do 2 to the 6th, that is 64. Alright, so the constant term would just be 64. So you don't want to just stop and say, well, it's going to be the 7th term. Yes, that's true, it is the 7th term, but we want to be specific and find its actual value. Okay, last example here. So we're looking to find this time the x squared term. So again, it's not immediately obvious to us which term number we're after. Right? Is it the first term, the second term, the third term, right? We don't know which term number it is, so we have to do a little investigating to identify the actual term number we're after. So once again, since this is a power of 4, we know that we're going to have 5 total terms. So let's just get a feel for what's happening to x. Well, notice how x shows up this time in the b position. And it's attached to that negative 3x, okay? Or it's attached to that negative 3 rather. So if it's in the b position, we know that it's going to start off, all right, with a power of 0. And then it is going to go up by 1, okay? So we can basically stop when we have found the x squared term. I'll just finish out the pattern here, okay? But you can see, hopefully, that the term we're after is going to be the third term. That's the one that's going to have an x squared in it, okay? So again, I've only written out part of the entire third term here. I'm only concerned with the part that has an x in it. Alright, so in our previous example we saw x as the so-called a term, but now it's the b term. So this is where it's starting with a power of 0 and going up by 1. So the bottom line is we need the third term. That means the r value is 2. So we use our binomial theorem. So the n choose r would be 4 choose 2. And again, I should write out the formula here. Alright. A to the n minus r times b to the r. So we have 4 choose 2. Again, rookies will say 4 choose 3. Or sometimes people will use 5, okay, instead of 4 because they know there's 5 total terms. Be careful, this number in front is always going to match your n. Okay, so 4 choose 2, the a is 2, and then we're doing to the 4 minus 2, and then the b is negative 3x. That's raised to the r. We said r is 2. So from there, go ahead and clean this up. So we clean this up here. 4 choose 2 is 6. And we have a 4 there. And then careful, we have a 9x squared once you distribute your power. So that's going to give us 216x squared. So the x squared term is 216x squared. Sometimes it'll say things like, again, find the coefficient of the x squared term. If it had said that, then you would just say 216. So that's it for binomial theorem. Again, this is what we call the binomial theorem. Please just write yourself a little note that it is used to find a specific term. Okay, so this is where we want just one term. Alright, yeah, you could use it to expand out your entire binomial. You could use it over and over and over, but it's embedded in that pattern that we saw when we did binomial expansion. Alright, so this is like the 6th consecutive video that I just did. Maybe 5, I don't know. Pretty tired, and it's time for bed. So, good night.